Okay, great. Should I start?
Yes,
The recording has started already. Yeah,
Yeah.
you can start.
Okay. Good afternoon, everyone. I welcome you uh, to this session. I hope everyone is doing well. I welcome to this workshop or training where we will learn what are the analyses we need to do in our PhD or MPhil data analysis and findings chapter, and how and what are the statistical softwares we need to use to achieve that result. That is our main goal here. But before going there, I would love to thank Dr. Ghazi sir to organize this awesome session. Truly shows how dedicated he is to improve his students' PhD journey and research quality, right? And I would love to congratulate all of you for coming this far in your PhD journey. I believe that PhD is the noble work for the society, and you guys are the contributor to that. So I mentioned earlier who I am, but for the sake of the recording, my name is Ikram Hasan. I'm editorial assistant at International Journal of Supply Chain Management, London, UK, and International Supply Chain Technology Journal, Texas, USA. And I'm also a teaching and research assistant at Independent University of Bangladesh. But more importantly, I'm your fellow PhD student here at UNIRAZAK. Hopefully, by this month, I can finish my PhD defense. Let's hope for the best. I have two supervisors. One is Honorable Professor Dr. Zulkifli Mohammed, who is the Deputy Vice Chancellor here. And I have another supervisor who is from Bangladesh. Um, and his name is Professor Dr. M.D. Mamun Habib. He is the head of Department of Management and the professor of Independent University of Bangladesh. So, uh, without any other further ado, let's start our session. Um, in our research, some of us have already done our literature review, and from that we have found the research gap. From there, we have found our problem statement, and there we discovered our variables, independent variables, dependent variable, and mediator variable, and these variables. Uh, from that variable, we have created a conceptual model like this one. Uh, okay, conceptual model like this one. So this is my PhD conceptual model. Um, I'll be sharing my PhD real data here. This is a compressed version of my PhD result because my full version is very large. It has sub hypothesis and all. So this is the compressed version of my conceptual model. And I will be sharing my real data. That's because I want to share my experience with you so that when you will do your PhD, it will be easy for you to, to do your research and data analysis as easy as possible because I face some problem. I have learned some tips and tricks along uh, the journey with my PhD, right? So I want to share with you and so that you can use that experience and make your PhD journey as easy as possible. So to give you a context, in this conceptual model, we can see that it has three independent variables: IoT, Internet of Things, digital financial solution, and blockchain database. And each of them are connected to the mediator variable, transparent physical and information flow. And we try to find out that is these three independent variable can ensure transparency in the agri-food supply chain or not, which is the dependent variable. And every variable has a line drawn here, and every line is a hypothesis, right? So we have three variable, three hypotheses, and one mediator dependent variable line, which is the fourth hypothesis. That's all so far we need to know. Okay, so based on this conceptual model, we have developed our questionnaire, right? We have uh, 27 questions. First three, first four questions are the demographic question, and other 25 questions are based on our variables. These variables and These are based on Likert scale, okay? From strongly agree to strongly disagree. Okay. Um, so what are the analyses we need to do in our PhD or infill research, right? So we need to do this analysis at least, all right? So I will explain one by one what are these, but now let's skim through what are this, okay? First one is a preliminary data examination, then is descriptive data analysis, then is validity and reliability analysis, which are done by exploratory factor analysis and convex alpha. Then is confirmatory factor analysis. It has two models, one is first order and second order measurement model. Then it's mm, structure equation modeling, and then the hypothesis testing. In this analysis, two analyses are very understandable, right? One is descriptive analysis, one is hypothesis analysis. So what are the descriptive analysis are the question, we have four descriptive questions like gender, age, right? Age group and everything. These descriptive questions analysis are descriptive analysis, which is very understandable. Another is hypothesis testing. You know, hypothesis testing is we have total four hypotheses right here. So is this hypothesis supported or not? This analysis will be covered by hypothesis testing. So you may ask that hypothesis analysis are the only analysis we need in our PhD, right? Because we need to know our hypothesis are supported or not. So why we need to do these other analysis, right? The thing is in PhD level, and if you want to publish a paper in a high quality journal, right? So what your examiner and also your um, mm, reviewer, your journal reviewer or something, journal editor, what they doesn't just want your hypothesis result, you know, they want an reliable and valid result. So how we can make sure that our hypothesis result are variable, is reliable and valid by doing this analysis, this validity and reliability and confirmatory factor analysis. This will ensure that our hypothesis testing results are valid and reliable. That's the whole purpose. All right. So let's go one by one now. First, let's discuss about preliminary data examination. All right. So I have created a questionnaire like this. Then I have imported this questionnaire to our. I have done mm, I have done our survey using Google Form. Okay, so I've exported this to Google Form, and Google Form will give a uh, and give the answer like this, like a Excel file or CVC file. All right, and it will be mostly based on words like female, male, customer, then farmer, you know. But the problem is SPSS and the statistical softwares do not understand this word male, female. They only understand words. Okay. By the way, can you see properly? Is there any problem? Okay.
It's
No, I think it's clear.
Okay.
small.
If
Yeah, I
it's
don't.
possible, you can
Small.
increase a little bit.
Yep.
Okay.
Yeah.
Increase the size of the. Yeah, this is good. Thank you.
Okay.
Mm.
So if you feel like I'm pacing too fast, let me know. If I don't understand anything, let me know. And also try to note down the steps, because although it is recorded, but when you do your analysis, probably you don't want to see 3 hours recording. You want to see your notes, right? So you can take the note of the steps. All right. Okay, so what we'll do now, we'll convert this word to number. So we can do it automatically in spaces as well. And we can also do manually here, but I will show you both manually and automatically, so that sometimes people mess up when they try to do it automatically in spaces. That's why I will show you both how to convert these names into numbers. So what I will do is I will drag it to this side and I will drag this questionnaire to this side. So first we'll convert our first question. Let's convert. We can uh, convert male to one first, female to two later. But if we do that, we'll face a problem. Let me show you first. Let's. What we can do is let's copy the male here. Let's click on Control and F to get this prompt. We'll click on the replace option here. Find. We'll paste the male, then replace it with one. Replace all. If we do that, we can see that the female says it's F1, Phi1. That's because inside the female wording, FE, then male, right? So that's a problem. So what we should do is we can convert female to two first, convert all, replace all. Then we can convert male to one, okay, and others to three. Okay, done. Then we'll go to the second question, customer. Let's copy from here, paste. Customer is one, replace all. Intermediary is two, replace all. And the farmer is three. Okay, replace all. Okay, the third question is yes is one, no is two. Yes is one, replace all. No is two. Okay, then we'll convert the fourth question. Let's move from the last one. Let's copy this, copy, paste is five. Then somewhat uncomfortable is four. Okay, then that's this one. Neither comfortable nor uncomfortable is three. Then somewhat comfortable is two. And finally, very comfortable is one. Okay. Now we'll move to our questions based on uh, variables, right? Before the first four was our our demographic questions. Now questions based on our variables. So it has 5 questions as well, 5 point Likert scale. So strongly disagree is 5. Which is all. Then disagree is 4. Replace all. Then neutral is 3. Okay. Then strongly agree. Let's convert that first. It's 1. And the last one is agree, which is 2. All right. So all of our questions are converted to numbers. Okay. Again, we can do it manually automatically in spaces. I will show you later on. But be, before going there, convert it here. I think it is easier, so that we don't face any problem later on. Okay. So now what we need to do is we need to import this data to spaces. Let's open the spaces file. Okay. So
Muzamil, do you have any questions?
yeah, do you have any questions so far?
Yes, I do.
Yeah.
What about if, let's say, there are any of the questionnaire that are not properly answered by the respondents? For
Yeah, we
example,
need,
they leave like one or two behind.
yeah. What we can
Thank
do
you.
is when you will create your Google form, every question we have an option to make it, mandatory to answer, right? When we create a Google form, every question there is a requirement to answer. So we have to click on that so that no one can skip any question. That's one thing we can do. Second thing, if we forgot to do that, and there are some people who skip one or two questions, we have to, um, if it's one or two questions out of 27 questions, we can average the questions from the other questions. If it's like, majority of the questions they skip, then we need to eliminate that respondent as well. Yeah,
I
that's
think
what.
for the sake of the time, I think we can keep all the questions chat box. Then we have separate session for Q&A.
Yeah.
Otherwise, it
Fine.
will be difficult, right, to continue. So first step is the spaces. After spaces discussions, we have a Q&A, and then we have MOS, and we have Q&A also. So keep all the questions. Even you can write in the chat box or keep it with yourself. Then we discuss later on.
So here we'll click on Open Data Document, this folder icon here. Let's click on that. So let's locate our file here. So what we need to do is we will click on Files type here and go all the way down and click on All Files. Okay. And here, this is the Excel file we have been working on. Let's click on that. So before importing, we have to check two boxes: remove leading spaces and remove trailing spaces. Why? I will explain later on. We need to click on check these two boxes. Let's click OK. Okay, so all the 400 respondents are here. Yeah, see, 400 respondents are here, and all the variables are here. We have 27 questions, so we have 27 questions here. So here we need to change 4 columns. Okay, one is name, then label, then value, and lastly the measure. Okay, so you see in the name section there is no gap here, no space here. Please indicate your gender, but there is no space. If there is any space here, spaces will show us an error. That is why while importing, we checked two boxes, right? So that there is no gap in here, no space in here. But in the label section, we can see there is a space. That's because there is no problem if there is a space or not. Okay. But make sure that in the name section, there is no space. Okay. Now we need to change this name so that we understand later on which question is what. So what we can do is we can like put it here as well, like before. Make questionnaire here. Our first question is what is the gender? So let's name it gender. Okay. Second question is role in agri-food supply chain. So just write role. Second is the third is user of MFC. Let's write user MFC. Fourth one is comfortable using MFC. So let's write comfort MFC. And all other 25 questions are based on our variables. So we have 5 variables, we have 5 sets of questions. So first is IoT. IoT has 5 questions. So what we'll do is we'll name it IoT underscore one. So why underscore? Because we can't give any space, right? So instead of space, we can give underscore. So I will just copy this one, paste it here, and name it 2, IoT 2. We have 5 questions. So we have 5 IoT, 4 and 5. Okay. Our second variable, DFF, let's name it digital financial flow, so DFF. So it has 4 questions. So let's name it DFF1. Let's copy that, paste it here, 2, paste, 3, and last one, 4. Okay. Second variable is blockchain database. Let's name it BCD, and it has 5 questions. So let's name it BCD1, name it 2, 3, 4, and 5. Okay. Now this is our mediator variable, and its the name is physical and information flow. Let's name it PIF. It has 5 questions as well. PIF 1, 2, 3, 4, 5. And our last variable, it has 4 questions, and 4 questions are left here. So its name is transparency in agri-food supply chain. So let's name it TASC. TASC 1. Let's copy that. 2, 3, 4. Done. So now we have to change 4 columns here. So we have completed this one. Now level. Demographic question, we don't have to change anything, but in the course based on our variable, these questions we will change it to this name. So what we can do, we can select the whole thing here. We can copy it from here, then select this and paste it. Done. The label is also done. Now let's change the value. Value means which questions means what. For example, male is 1, value 1, label is male, right? Add. Then female is 2 and others is 3. Oh, okay. The second question, let's name it customer of agri-food supply chain is 1, 2 is intermediary of agri-food supply chain, and 3 is farmer. Add. Okay. This one is yes, 1 is yes, 2 is no. And okay. And last demographic question, One is very comfortable. Two is somewhat comfortable. Three is neither comfortable nor uncomfortable. Four is somewhat comfortable, somewhat uncomfortable, sorry. And last one, very uncomfortable. Okay, done. So from here, our variable-based questionnaire started. Okay, strongly agree, one. Two is just agree. Three is neutral. Four is disagree. And five is strongly disagree. Okay, so do we need to manually change everything here? No. What we can do is we can copy this one and all others, all these are same, right? So just select all of that, click, right click on that, paste, done. Okay. And last column we need to change is measure. First first four questions are nominal questions, right? There is no number and anything. And by the way, this one is scale based, 5-point Likert scale. So fourth number question is scale based question. Okay. And all of our variable based question are scale based question. Just copy that. Let's select all of that. Let's paste it. Done. So since we have already defined, okay, by the way, first let's save this file. We don't want to lose it. Training. Let's name it main data. Okay, save. So since we have already told spaces that these are the values, so one is what, two is what. So we can go to data view here. Let's make it big. Here there is an option called value labels up here, right? If you click on it, it will if we click once, it will show our the words. If we click once, another one, the time it will show our number. So we can do it automatically here. But why did we do it in spaces? Sorry, Excel, so that if we don't face any problem here. Sometimes defining one is what, two is what is difficult. So that's why it's the easiest side. So I face so many problems doing this, so I'm giving you the easiest way to do it. All right. So okay, we are done with our conversion data. Another thing, now next thing is data descriptive analysis. But before going there, we need to check another thing. That is there any missing value or not, right? So we can check it manually, but there is ocean of numbers, so we can see is there any missing value or not. As I mentioned earlier, to avoid this missing value, what we can do is while we are preparing our questionnaire, we make every questionnaire required to answer so that no one can skip our question, right? But in case there is some missing value, so how to find it, so it's very tough to find manually. So what we can do is let's create a uh, artificial respondent here. Suppose he didn't answer this question. So how to find this out? So what we can do is we can go to analyze, then go to descriptive, then go to frequencies. Then the left box here, left box is all the questionnaire we have. We have 27 questions, and right box is the questionnaire we want to work with. So we want to see that is there any missing value in this all the 27 questions on, is there any missing value on the all the 7 questions or not? So we'll select all of that. So how to do that? I will click on one question, then press Ctrl A to select all. Then click on this middle button to move it here. Then click on OK. We'll get a sheet like this, a table like this. Here is missing option here. You can see there is no missing value 000. Only one missing value is here, DFF, which we have artificially created, right? So that is how, this is a one way to find out is there any missing value or not. Okay. So if there is missing value, what should we do? We should eliminate the whole thing, eliminate the respondent. Because if there is a missing value, we'll face problem determining the correlations. Okay, so just clear it. Okay, so our data is ready to analyze. Okay, so what is our next analysis? This descriptive analysis. Descriptive analysis means we know we have 4 descriptive questions. So analysis of these questions are descriptive analysis, right? So let's go to our spaces file. We'll click on analyze, descriptive, frequencies again. We'll move all of them here. We want to work on only first 4 questions, which are descriptive questions. We'll click on statistics, standard deviation, variance, range. We don't have to click on range. Maximum, minimum, mean, median, mode. Click on continue. You can take notes uh, because we will covering so many analysis so that you remember uh, the steps, you can take a note. Okay, let's click on continue. Let's click on chart. We want to see them in pie chart. Let's suppose we want to see the pie chart of first 3 questions and last question we want to see in bar chart. So what we can do is let's click on pie chart and click on frequencies, click on OK. We want to see this one in bar chart, so we'll work on that later. We'll work on now just first 3 questions. Now let's click on OK. So we'll get 3 tables and 3 pie charts because we are analyzing first 3 questions, right? So how to import, how to export these tables and these charts to our Word file? What we can do is we'll select this one. We'll hold on the control here. We'll select this one. We are selecting the first 3. Let's right click on that. Let's copy that. Let's open a new Word file. Let's name it output. Let's save this one. Let's save it in our directory. Okay. Here. So we have already copied from the spaces. That's it here. Let's copy it again. Let's paste it here. As simple as that. Then what we'll do is we'll go to output again. So you see in this pie diagram, there is no frequencies, right? There is no number, like how many males are there out of 400, right? So what we can do is we can double click on that, double click on a diagram. We'll click on the second option, show data levels. We'll click on that. Okay, now we can see the data levels, right? Yeah, we'll do the same thing here. We'll click on that, the second option, double click, second option. Yeah. Now we can see that out of 400, 287 respondents are male, right? So what we can do is we right click on that. Let's click on copy. We'll go to output. We'll paste this diagram under the gender option on gender table. Then let's copy the second one, paste it here. And the last one, let's copy that. Okay. Now we can, interpret in words. Okay. And we have another question left from the demographic analysis. Let's go to analysis, descriptive frequencies again. We have done with these three. The fourth one, let's click on statistics. We can see that statistics has spaces already know that what we have selected last time. So it has recorded. So we don't have to do anything here. Charts, this time we need bar chart, right? Let's click on continue. Let's click on OK. Great. We'll double click on that. The second option. Done. Now we'll click on that and this one. Let's copy both of them. Paste it here. Done. Our demographic analysis are done. Okay. Now what we need to do? We need to analyze the validity and reliability analysis. For that, we need to analyze exploratory factor analysis and convex alpha. Okay. So there are some threshold we need to maintain, we need to meet. For example, for exploratory factor analysis, we need to check three things. One is factor loading has to be 0.4 or more than 0.4. AVE has to be 0.5 and composite reliability has to be 0.7. And these statisticians, they has gave us these thresholds and their reference are here as well. I've provided here. You can use it from here. Okay, so let's work on factor loading first. So this reliability and this factor loading, AVE and composite reliability will show us that is the items within variables are related or not. Let me show you, then it will be easy to understand. So first we'll do the factor loading analysis first. Okay, so to do that, we have to go to analysis, then dimension, reductions, and factors. So we need to see our first 4 questions analysis are done. Now we will analyze the all 25 um, uh, um, questions from our variables, right? So we'll select all of that. We'll move it to here. Then we need to click on rotation. Here we need to click on Varimax rotation. Let's click on OK. Then we need to click on options. Here we can see that our factor loading has to be 0.4, 0.4 or more than 0.4, right? So what we'll do is we will click on surface small coefficient and make it 0.4. Sorry, 0.40, right? So let's click on OK. So here we have changed 2 things. One is rotation, Varimax. Another thing is options. Our threshold is 0.40. So here it is. Okay, let's click on OK. So from here, what we need to do is here, this is rotation component matrix. In the left side, in this index, we can see that at the second last option is rotation component matrix. We have to click on that. So this is the table we need. Okay, so here we need to check 2 things. One is there any numbers which is less than 0.40? So we have already mentioned while doing this analysis that our threshold is 0.40, right? So 0.40, right? So if there is any value which is less than 0.40, it will be blank. So if there is any blank or less than 0.40, we need to eliminate this question. That is why I recommend that when you create your questions under per variable, try to make minimum, try to generate minimum of 5 questions at least, so that 1 or 2 questions you have to remove it later on. It will face no, you will face no problem during your research. Okay, so two things we need to make sure. One is it uh, less than, is it more than 0.40? So you can say that all of our numbers are more than 0.40, and is all the variables question is falling in a same group. For example, IoT have 5 questions, so it has five questions in a group, right? They are in a group. But the problem is we have 5 variables, right? But we can see that Spaces has given us 6 groups. So we already has a problem here. So where is the problem here? One is DFF. It's not falling under DFF group, right? It should be here. Another is PIF. It should be here, right? It's here. That means SPSS are telling me that these questions is not fitting with other questions based on um, their particular variable, right? So that's why what we need to do is we need to eliminate this DFF4 and DFF5. These two questions we cannot work on it. It will give us error later on. So we'll make a note. Let's go to the output section. Let's say that DFF4 and another one is PIF5. PIF5. We need to eliminate it. Okay. Now the thing is, we every time we do not need to go to analyze, then you know the dimension reduction. SPSS has recorded your previous actions. Okay, so what we can do is we can go here, recall recently used dialogues. Here we can see that reliability analysis, frequency analysis, and factor analysis. Now we are doing factor analysis. Let's click on that. So we need to remove 2 questions: DFF4, DFF4, this one, and PIF5. PIF5. We cannot work on these two. We can work on this rest of the questions. Let's click on OK now, because Spaces is already know our rotation is varimax rotation, and option is 0.40. Okay, let's click on OK. Let's click on rotated component matrix from here. Now, this is our main table. We have 5 questions, 5 variable. We have 5 groups, and all of them are falling under same group. IoT has 5 questions. It's falling under one group. SPSS is understanding that these 5 questions are in a particular variable, right? So what we'll do is we'll copy this one, copy this table, and paste it in the output section. Okay. Let's move it to another page. Okay. So our first analysis is done. Our first one is factor loading, which is now more than 0.4, and all are falling under their respective variable. All right. Now we need to do AVA test and composite reliability test. To do that, we have to go through series of activities, series of calculations. To make things easy, I have already created a Excel file for you, EFA calculation. Let's click on that. This one. So you see, we have 5 variables. So we have 5 section here, tabs here. So if you have more variables, you can duplicate one and work on from there. So what you need to do is, let's put this one here. Let's go to output tab here. All you need to do is just let's copy um, uh, the name of the variable, questionnaire items for the first IoT. We'll paste it here. We'll copy this one. We'll paste it here. And it has 5 items, right? So in the count section, we'll put the 5. It will automatically calculate us the AVE and composite reliability. As simple as that. Okay. I will, Dr. Ghazi sir will share this Excel file with you so that you can use it. Okay. Then the next variable. We have 5 variables. So let's go here. Let's copy this one. Let's paste it here. Copy this one. Paste it here. Okay. So it has 3 questions, right? So it is originally 4 questions. We had to eliminate one, right? So count is 3. Okay. So it has generated CV and AVE. Okay. Third variable, this one. Let's copy this one. Let's paste it. Copy this one. Paste it. We have 5 items. Let's write 5 here. Done. Then PIF. It's a mediator variable. Paste it here. Let's copy this one and paste it here. Originally, it has 5 questions. Now one removed. So it has 4 items now. And last variable. Let's copy, paste it here. Copy, paste it here. It has 4 items. So let's write 4 here. Done. Our AVE and composite reliability is done. And let's see that since we know that AV has to be more than 0.5 and composite reliability has to be more than 0.7, we can see that it is more than 0.5 and this is more than 0.7, this is more than 0.5, more than 0.7, this is also more than 0.5, 0.7, the same thing, and the same thing. So how to present all of this in your dissertation? So I've created another table to present your result. So what you need to do is we'll copy this one, paste it here, paste just value, to copy this one. This is the factor loading section, paste just value. Now we need to copy composite reliability and AVE. Here it is. Just copy this one, paste value. Okay. So we need to do the same thing for all of that. Let's copy this one, value, copy this value, copy this too, value. Mm, mm, value. Okay, mediator variable. Okay. And the last one is this one. Oh, we need to input these values as well. Okay. CP, PIF, and last one is this one. Okay. Now, only thing we need to do is analyze the comeback alpha. So how to do that? We'll go to a species file again. We'll go to analyze scale reliability analysis. You can note it down. Analyze scale reliability analysis. Then we need to find out the convex alpha of first variable, and first variable has 5 questions. Let's move it here, and it's already shows alpha, so we don't need to do anything. Let's click on OK. And the last box is the result, and according to this one, it has to be more than 0.7. Okay, so it's more than 0.7. So it's 0.787. Okay, this one 0.787. Okay, let's go here again. Let's click on recall data, recall dialog here. Let's click on, no, not this one. You have to go to again here, scale reliability analysis. So we've done with this. We will move it here. Second variable has 3 questions, 3 items. It has 4 items, but DFF4 is eliminated, right? So let's click on OK. 0.901. Okay. 0.901. Okay. Then what we'll do is we'll go to here again, click on this reliability analysis. We'll move here. Next variable has 5 items. Click on OK. 0.798. 0.798. Okay. So here again, reliability analysis. It has 5 items, but we'll choose the first 4. The last one is eliminated. 0.952. 0.952. The last one is this one. 0.911. 0.911. Done. Our uh, exploratory factor analysis table has been done. Great. So what we can do to make it uh, look pretty, we can do this. Merge cell. This is what we can do to present our data. Yeah, I think you get the point. So this is how we analyze factor loading um, and reliability and validity. So what is reliability and validity? Let's briefly talk about it. Reliability is all of our questions are in the same group. So you can see here they are in same group. That means our um, you know the thing is everyone has selected. We have question like in Likers, right? Let's open our question. So everyone is either strongly is disagree to disagree. They have answered 4 to 5, or either they have answered strongly agree to disagree. If some 50% of them has selected 4 and 5, and 50% of them have selected 1 or 2, that means it's not reliable. Your data, your respondents' answer are not reliable. So that is why we have to do reliability test and also validity test. Validity test means, you see, the we are not targeting in a particular direction, right? If everyone answered the same thing but it's not in a direction which you want, that then it's not working, right? For example, our target is to get to see is there any is independent variable can ensure transparency in agri-food supply chain or not, right? So we have a target. So everyone answer has to be similar, and it has to target a particular place, right? So that is we have ensured here by doing um, exploratory factor analysis, factor loading, AVE, composite reliability, and convex alpha. All right. So with that, we have completed the um, our mm, yeah reliability and validity analysis. So do you have any questions so far? Yeah, please go ahead.
Thus, you have completed the SPSS, right? SPSS
SPSS part.
analysis.
Yeah,
Yeah.
yeah.
Okay. Okay. If there is any questions, we have about 5 to 10 minutes. Then we
Yeah.
discuss about if any reflections or any like comments or clarifications of some of the points of the analysis, and we
Mm,
can see.
yeah. So I think we can take a like 15-minute break, and if anyone has any question, we can answer that. Okay. After this break, we'll move on to AMOS part,
Yeah.
AMOS
If
analysis.
there is less questions, then we can move after 10 minutes.
Right, right.
Right. Yeah. And I think Dr. Sapuan, you are raising your hand in the beginning. Dr. Sapuan, do you have any questions or clarification you can ask Mr. Hasan?
Okay, I just have one question. Some of the student, their liquid skill is different with like what you what display. They're starting with the very strongly
Mhm.
agree to
Like our
number
skill
five,
base. Yeah.
and then strongly disagree. They put number one. So
Oh, that's not a
how
problem.
it's
That's
not a
not the
problem,
issue.
is it right?
Yeah.
Okay, right. That's all. Okay, thank you.
The converse alpha will check the majority what answered. It doesn't
Okay,
matter it's 1 or 4. Yeah,
all right. Thank you.
got it. And there is no, hard and fast rule as well that strongly agree has to be 1. There is no rule like that.
Similarly, they can use the different scale. Like if someone
Mm,
wants to use the 7-point scale
7 point, like, right,
or 9-point scale, is also the same way, right?
right.
Yeah. I think if there is no questions, you can start like the second part, the yeah, the most part. I think you can go ahead. Then we can finish early if
Right.
possible. Yeah.
Hmm. So far, the analysis we have done is based on particular variable, right? Let's go here. Suppose IoT, it has 5 five questions, and we have in the factor loading, we have seen that is these five questions individually is supported or not. That's what we checked. Then we check that is five questions together, uh, is it consistent or not in the contact alpha test. Um, so it's all about particular variable, right? Now we'll see that if two or more variables, if we compare together how they fit. To analyze that, we have to do uh, AMOS, and we have to create a model to see that how as uh, two or three variables together how they fit. That's we need to check now. So what we can do is let's save this one. Now we'll open up the AMOS file. First thing we need to do is we need to import the SPSS file here. So how to do that? We'll click on this one, select data files. Now click on file name. Then we'll go to our directory. Let's find it. Where is it? Okay. Main data, right? We name it main data. Let's click on that. We can see that we have 400 respondent here. Let's click on OK. Now what we will do is move it here. We will we'll see this rotation component matrix. You can see that our first variable has 5 questions, right? So now what we'll do, we'll click on this one, draw a latent variable, right? We'll click on this one. Then we'll click here. One time, it will give us a circle. It has 5 questions. Let's click 5 times inside the side circle. Okay. 1, 2, 3, 4, 5. Okay. So next variable has 3 questions. Let's click on once for the circle, and inside the circle we have to click 3 times. 1, 2, 3. Next has 5 questions. Click on 1, 1, 2, 3, 4, 5. Then next one has 4 questions. Let's click on 1, 1, 2, 3, 4, and last one has 4 questions as well. Just 1, 1, 2, 3, 4. Now we need to organize it. So first thing we will do is we'll rotate it. So let's click on this rotate object here. Let's click on that. Let's make it left hand side. We'll do the same. Every time we click it, it will clockwise rotate one time. So we'll put in the left side. We'll do all of them the same way. Now what we'll do is we'll move the whole thing. So how to move it? We'll click on this track icon here, move object. So we'll click on that. So you can see that it is not moving the whole thing, right? So what we'll do is let's Control C here. Let's click on this one. This says preserve symmetry. Okay, let's click on that. Then we'll click on the track icon here, move icon. Then we can move the whole thing, you know. So we'll put it here. Let's move it like this. Let's move it like this. Okay, so now move it here. Like this. Try to make it as similar as possible. Here. Here. Okay. The last one. Okay. Next thing we want to do is we need to, resize these circle and squares. So how to do that? We'll click on this change the shape option. Let's click on that. So we can change the shape of it. But the thing is, if you want to manually change each of them, one will be bigger, one will be smaller, there will be some human error. What we want is we want all of the size of the circle are the same. So how to do that? We'll click on this thing, pointing option here, select object here. Let's click on that. Let's select on this one, this one, this one, 5 variables. Then we'll click on change object shape. Then all of them are same size. Okay. Then we'll also change this one as well. This one as well. Okay. Now what we will do is we'll try to make it as close as possible. Okay. 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 Now let's start naming it. Let's deselect all of that. We have selected 5 of them. So let's deselect all of that. So how to deselect it? Click on this one. Deselect all object. Okay, done. Now we have to name this. So let's click on this one. List variable in dataset. Okay, it will give us the list of 25, 27 questions. 27, not 27 questions. We have deleted 2 questions, right? So this will give us the list of all questions. What we'll do is we'll just drag and drop the questions. Drag and drop the questions like this, the items like this. Okay. The first one has 5 questions. 5. Second one has 3 questions. 3. Okay. So it seems like uh it's like close, very close to each other. So let's make a gap here. Okay. Okay. So DFF4, we will not use that because it didn't support in the factor loading. So it has, then BCD has 5 questions. 3, 4, 5. It has 4 questions. 4. PIF 5 is eliminated, so we will not use it. It's 4 questions. Okay. Now we have to name this one. We'll double click on this circle, the first one, IoT, and name it IoT. Okay, what's going on? IoT. Okay. Then let's click on this one. Let's name it DFF. Let's click on this one. Let's name it BCD. Let's click on this one. Let's name it PIF. Click on this one. Let's name it DASC. Okay. Another thing we need to do is that you can see that every last question has this one here. In the arrow, there is a 1 here. If this is the regression, we need to change it. We need to tell Amos that this is the first question. Okay. For the first one is the first question. So what we'll do is we'll double click on this arrow. We'll click on parameters. We'll delete this regression. We'll click on the first arrow. We'll give 1 here. This is the first question, right? So we'll do the same thing here. Delete this one. First question. Click on 1. We'll do the same thing here. Delete this one. click on one, one. Okay. Now, what we need to do is we need to name all of this. So these are errors, E1, E2, but we don't want to do it manually. It will take time. So what we'll do is we'll ask Amos to do it. So what we can do is we go to here, plugins up here. Here we will click on name unobserved variables. Spaces will automatically give name to this error terms. Okay. All right. So this is the model. So first analysis we need to do right now is first order measurement model. Okay, in the first order measurement model, there is no dependent variable. We just want to see how each other, all five variables work together or not. Okay, to do that, how to make sure that their model, this model are fit, we need to check four things. One is um, chi-square by degree of freedom has to be less than 5. CFI and TLI has to be more than 0.9, and RMACA has to be less than 0.1, and all the references are given below here. Okay, so you have to check four things: chi-square by degree of freedom, CFI, TLI, and RMACA. Okay, so what we'll do is we have to connect all of the variables together. We have to click on this one, draw covariances, the double arrow, double-ended arrow. So what we need to do is we need to connect all of them together. But sometimes we can miss something. We can give extra arrow and so many things. So we'll try to do it automatically. So what we will do is we'll remove these arrows. We will click on this one, selection option here. We'll select all of the five variables and we'll ask Amos to draw arrows. So how to do that? We'll click on plugins again, draw covariances. The Amos will automatically draw the covariances. Then we'll select one of the arrow and drag it like this. Okay. Then we'll click on this magic wand button here, touch up variable, magic wand. Then we'll click on each variables so that it looks good. Then click on this change shape option again. Just select one of them and just try to make it look good as good as possible. All right. So we are done with this. So we'll deselect all. Now we have to analyze that um, if this model fits these four criteria or not. Okay. So what we need to do is we need to click on first this one, analysis properties. We'll go to output section here. We'll click on standardized standardized estimates. Okay, let's close that. Now we'll click on analyze. So how to do that? Click this one, calculate estimates. It will then the Amos will calculate estimates for us. So let's click on that. Oh, first we need to save this file. Okay. So what we'll do is we'll go to our directory here. Let's create another folder. Let's name it Amos models. Okay, let's name it. This is first order CFA, confirmatory factor analysis. That is what we are doing, right? Confirmatory factor analysis, first order. Okay, let's save it. And this one will came handy. Okay, so our analysis has been done. So here we can see that there is a red up arrow. This is the show output option. We can see that bunch of numbers. Click on standardize. So where to find the degree of freedom, CFI, TLI, and RMACA. So we need to go to here, view text, and model fit. Here we will find all four results. The thing is, um, there are so many, information here. So we don't want to, waste our time here. What we can do is, let me give you a shortcut. So I've already write down uh, this is the equation. So what you will do is we'll copy this one, copy the whole equation, copy, we'll go to Emos. Then what we will do is we'll click on this one, input section. This is output, this is input. Okay. In the input section, we'll click on title. We'll click any blank canvas here, anywhere. We click on here. We'll paste the equation here. We'll click on left align. Let's click on OK. So let's click on the track icon here. Let's move it here. Okay. So here the four threshold we need to match, right? Now let's click on calculate estimates. Okay. Now we'll click on this output result. You see, now we have directly get the result of the model. We know that chi-square by degree of freedom has to be less than 5. It's less than 5, 2.5. TLI and CFI has to be more than 0.9. These two are more than 0.9, and RMCA is less than 0.1. So its RMAC is less than 0.1. So we got the first order factor confirmatory factor analysis. So we need to import this model to our Word file, right? So how to do that? We'll click on edit here. Let's click on copy to clipboard. Okay. We'll go our output file here. Let's move to the next page. Let's paste it here. We just need to paste it here. So there is a uh, red highlight here. So why is that? Let's change it. Let's copy it again. Paste, it's gone. Okay. Now what we can do is we need to interpret it. So how to interpret this? So I have also uh, wrote the interpretation here as well. Yeah, here is the interpretation. What you can do is just copy this one. Here you can say that the first order CFA generates something like that. So it didn't copy it entirely. Why not? Mhm. Let's copy from here. CFA generated this, and our chi-square by degree of freedom is 2.57, 2.57, TLI and CFI 0.935, 945, 0.935, and 45, and RMSEA is 0.063. 0.063. So since our model fit all four criterias, so first order CFA or measurement model is a good fit for our research. That's it. Okay. So that is how our first order measurement model is complete. Now we need to calculate second order measurement models. So why it's models? Because second order measurement can be many models or just one model. Okay. Why? The many dependent variable you have, the many models you need to create. For example, it has this conceptual model has two dependent variable. Why? One is, you can see that one is dependent variable here, transparency in agri-food supply chain. But you can, if you think about it, this moderator variable is also dependent on these three variable as well, right? So we have two dependent variable. One is this one, this part, and one is this two part. Let me show you so it will be more understandable. All right. What we'll do is we'll go to Amos here. Let's copy this one. Let's save this one first. Control S to save. Okay. Now what we'll do is we'll go to Amos model. This is the first order measurement model. We'll copy this one and paste it. We'll make our life as easy as possible. Okay. So second order CFA model 1. Okay, let's open this up. What we will do is we'll try to draw like this, independent variable to mediator variable. So what we'll do is here there is no, we'll just create based on one dependent variable. So we will delete this last dependent variable. So let's delete this one. We'll click on this one, erase object. We'll delete this one. And here, this mediator variable is the dependent variable, right? Here, mediator variable is dependent on these three variables, right? So what we'll do is we'll delete this options here, arrows here, and let's change the orientation of this page. So how to do that? Let's click on View, Interface Properties. Let's click on Landscape. Let's put it to Landscape. Okay. Now, what we will do is we will move this one here. So how to do it? We'll click on preserve symmetry button here, then move track here, then we'll move this one directly here, and we'll move this one here and here. Okay. Then we'll click on rotate option here. We'll rotate this. Let's click move selection here. Move like this. Now we'll give a relationship. How to do that? We'll click on this arrow. One ended path arrow, single headed arrow. will show the relationship, right? Now this model is kind of look like this, right? This one, independent to mediator variable, not dependent. We are not including dependent variable now, right? Just like this, right? Okay. But this is a dependent variable, so it needs a error like this, but this is not error, this is residue. So what we'll do is we'll click on this one, add unique variable. Okay, we'll click on this one. Since every dependent variable needs a circle like this, okay, you will understand more later on. So we'll give on this dependent variable this residue and ask SPSS to name this one. So how to do that? Let's click on plugin, name unobserved variable. Okay, let's reshape it because it's looking very big like this. Let's click on the magic one option here. Okay. Okay, perfect. Now we will calculate. So how to calculate? Let's click this one, calculate estimates. Now we'll click on this one, show output. We'll click on standard estimates. So you can see the first one is less than 5, TLI and CFI more than 0.9, and RMSA is less than 0.1. Perfect. Now we need to copy this one. Copy. We'll paste it here in our output section. We can copy the same thing here. The interpretation. Here we can write that the second order CFA model 1, okay, so same thing. Then we need to change this. I'm not changing here, but you get the point. So thus the second order model 1 model is fit. Okay, next what you need to do is second order model 2. Why? We have another dependent variable left, this one. So we need to create a model for that one as well. We have to check the model fit for that one as well. Okay, so what we'll do is we'll go to here as well. We'll click on, we'll copy just like last time. First order measurement model, let's copy it and paste it here. And let's change the name like this. Let's copy this name. Let's paste it here. Second order CFA model 2. Okay. Now what we will do is we'll delete all of this. We'll just keep these two. Why? We are trying to draw just these two. Last time we did independent variable and mediator variable, and this one was the dependent variable. This tree was the mediator was dependent on this tree. Now we will drawing just the mediator and dependent variable, and dependent variables depending on this mediator variable, right? So we'll delete all of that. Okay. Let's change the orientation of the page. View, interface properties. Let's make it landscape. Apply. So what we will do is we'll also remove this double-ended arrow as well. We'll click on this symmetric option here, then move track. We'll move it here. We'll move it here. Then we'll rotate it like this, rotate it like this. Now we will show the relation. Now draw path single-headed arrow, right? Right. Now it's kind of look like this, right? This part, just this hypothesis 4, right? So since I told you that every dependent variable needs a residue, so like this, we'll click on this one, add a unique variable. We'll give this one a unique this residue, and then we'll ask a species to name it, name unobserved variable. Let's make it a bit short. Okay, okay, get done. Now what we'll do is we'll calculate. Let's click on calculate estimates. Let's click on this one, output show standard estimates. See, chi-square by degree of freedom is less than 5, TLICFI more than 0.9, and RMACA is less than 0.1. Okay, so we'll copy this one as well. Copy, we'll paste it here. We'll do the same thing. Copy. This is the second order model 2. Second order model 2, right? You can change this based on these results, right? Yeah. So far what we have done is uh here is one, and another model was model 1, this one. Not this one. Okay, got it. So here we have pasted it. So this one look like this part, and this one looks like this part, right? Now we need to combine all of them like this, just like conceptual model, and this will be this model we'll call structural equation model. Okay, this structural equation model, by combining this model and this model, this one and this one. So how we'll do that? The structural equation model, we'll go here again, we'll copy the first order CFA, which is coming very handy now. Let's copy this one, let's paste it, let's name it structural equation model, SEM. Let's click on that. Let's change the page orientation. View interface properties. Let's change it to landscape. Apply. Now what we will do is we'll remove these lines. Okay. We'll click on piece of symmetry, then click on this move up track here. We'll move it here. We'll move it here. We'll move it like this. We'll move it here. Okay. Now what we will do is we will change the orientation like this. Then let's move it here. Okay. Okay. I think we are good to go. Okay. Now we'll draw the relationship lines. here, 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 and here. Let's click on magic wand. So that it makes the line looks good. Okay. Now let's move this one like this because it's just, this line is uh crossing this box. So let's do it like this. Okay. Now this model looks like this one, right? Three independent variable, moderator variable, dependent variable. Three independent variable, moderator variable, dependent variable. But this mediator variable is depending on this three. So since it's depending on this three, so we need to add residue here, and this one is depending on this one, add another residue here. Okay. Now we need to name it. We will ask a species to name it. Name unobserved variable. Just resize this one like this, like this. Okay. Okay. What we can do is we can select this one too so that the size remains the same. Okay, now they look similar. Okay, let's unselect this. Okay, now we can run the calculation. So here is the calculate estimates. Let's click on that. There is the output section here, standard estimates. So chi-square by degree of freedom is less than 5, TLI and CFI more than 0.9, and RMECA is less than 0.1. So our structural equation model also supported. So what we'll do is we'll edit this one, click on edit, and let's click on copy. We'll go our output section here. Let's go to another page. Let's paste it here. You can copy this one again. Here we can write that. Our structural equation model, the structural equation model, ACM, you need to change these 4 value based on this one. Thus, this model is a good fit. Okay. So we have completed structural equation model as well. Now we have to came to the our main point, hypothesis testing. So this for hypothesis testing, right? That means the relationship between these one-ended arrow lines, right? So how to do that? What we need to do first, we need to calculate the average of this questionnaire and create it one variable. So how to do that? We can make it manually. We can do it automatically as well using AMOS. I will show you both. So let's go to spaces first. What we'll do is we'll go to transform. So far we have worked with analysis, right? Analyze. Now we'll go to transform compute variable. Okay. Okay. Mm, 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 mm. We'll click on here, statistical, and click on mean. Mean is average, right? Let's double click on that. It will give us a mean here. Let's delete this one. Let's name it just IoT. Okay. We'll click on this one. First one. We'll move it to here. Let's click on a comma space. Then the second one, comma space. The third one, comma space. The fourth one, comma space. The fifth one. Okay. Then let's click on OK. So it has computed the mean value. If we go to our species file, you can see that there is another section here, which is IoT. It's not IoT 1, 2, 3, 4, 5 anymore. It gives us a separate column which says IoT. Doing this, like you can do the same thing for other 4 variables, but you get the point. We'll do it automatically now. I'll show you how to do it automatically. So what we'll do is we'll close this first. Let's save it first. Save and close. Save and close. Save and close. Okay. Now we'll go to the first order CFA again. We will delete this one, this index, fitness index. We'll ask species to impute these items into IoT. So what we'll do is we'll go to analyze here, then click on data imputation. Then we'll click on file name. We'll go to our directory. Yeah, okay. Let's name this file main file underscore impute, so that we know that it's the imputed version. Okay, let's click on save. Now let's click on impute. Okay, so our imputation is done. Let's click on OK. Let's close it out. We can close this out. Okay. Now if we go here, we can see that there is 2 files. One is main data and another is Amos has generated imputed version. So what we'll do now, we will open up the Amos again. Let's click on here, file, new. We'll create a new file here. We'll change the orientation of this page. Let's click on view, interface properties. Then let's click on landscape, apply. Then what we'll do is we'll click on this one, select data files. Let's click on file name. Last time we selected the main data. Now we're selecting main data impute. Okay, it has 400 responded again. Let's click on OK. Now what we'll do is, last time what we did is for every variable we click on this one, then we create a circle. It has 5 questions. We did like this, right? But this time we will not do that. What we'll do is we'll click on this one, list variable data. You can see that at the end it has imputed 4 variable, five variable. We have 5 variables, so we have 5 variable. If we go here as well, we can see that Emos has created these 5 variables, right? Imputed version. Okay, so let's go here. Now what we will do is we'll drag and drop this imputed version one. Okay, this one. this one here and here. Done. Okay. So now what we will do is we will change this name. So how we will do that? We'll just put it here. We will go our questionnaire here. First one name is IoT, right? First one is IoT. Let's copy this one. Copy. Let's double click on that IoT. We can't change variable name here. Then spaces will MOS will give us error. We'll change here. We'll add variable labels. Let's paste it here. Okay. Then we'll click here as well. We'll not change variable name. We'll just change a variable level. The second one is DFF, digital financial flow. Let's copy that. Let's paste it here. DFF. Let's click on BCD. That means blockchain database. Let's copy that. Let's name it BCT. Then PIF. Let's copy that. Physical and information flow. Let's name it PIF. Okay, the last one is TASC, which is transparency in agri-food supply chain. Let's copy that. Let's paste it here. TASC. All right. Okay. Okay. Now we need to reshape the boxes, right? So what we'll do is first let's move this one here, 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 yes, like this. Select all 5 of the variables so that their size are identical. Let's click on reshape option here. Okay, done. All of it the same size. Let's deselect all. Let's click on the track icon here. Let's just do this. Okay. Now let's show the relationship. This one here, 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 and this one. And we need to covariance length between these 3. So what we can do is we can select this, click on select button here. We'll click on these 3. We'll click on plugins, draw covariances. So it has drawn covariance between 3. We'll just make it inside here. Well, deselected symmetry. We'll click on track icon here. Let's deselect all. Click on track icon so that we can move this like this. All right. Now it looks exactly like our conceptual model, right? Like this. Okay. Let's click on this magic one but option so that it looks good. All the arrows looks good. Okay. Okay. Then okay. Done. Since these 2 are the dependent variable, so you know what to do. We need to add residue here, and here, right? And we need to ask a species to name it. Let's select these 2 and change their shape. That's okay. Done. Our hypothesis path model has been created. Now we'll do analysis, calculate the analysis. But before going there, what we need to do is we need to click on analyze properties, we need to click on output, we need to click on standardized estimates, what we did last time, but for this time we need to select indirect, direct, and total effects box as well. You have to check this one as well. Okay, these three. First one is already selected, standardized, and this one. Okay, now let's run the calculation. This time we are not doing model fit test, the four thing. We are just saying that our hypothesis has accepted or not, right? What we'll do is we'll click on calculate estimates. Oh, we have to name it. So the name is hypothesis. Just right. Let's write the hypothesis. Okay, let's save it. So the calculation has done. What we do is we'll click on this output section, standardized. We'll just click on edit and copy this one. Let's copy this in here. Let's paste it here. All right. Now, how to know our hypothesis has supported or not? How to find that out? We need to go to here, view text. Then what we'll do is we'll extend we'll expand the estimates option here. Then we need to expand the scales option here. Then this regression weight is our result. This one, this one, this one is our result. So we'll copy this one. We'll copy this one. We'll paste it here. Paste the table here. So how to know it's supported or not? Anything, this p, first we need to check the p value. If the p value is less than 0.05 is supported. If it's more than 0.05 it's not supported. So how I'm telling this, what is this then? Three stars, that means it's less than 0.005, so it's supported as well. So if you click on that, it will say that PIF is significantly, there is a significant relationship here because this is less than 0.001, right? Then if you click on the first one, it's not less than 0.001. That means it's not significant, you see, because it's not less than 0.05. But if you click on that, it is less than 0.05. So there is significance, right? So our two variable did not support, but these two variables did support. So how to interpret that? How we will interpret this? So I have also created another Excel file here to present your hypothesis result. Just time to open it. Okay. So this is the table. So we have four hypotheses, right? So we'll copy this one, we'll paste it here. Wrap text here. Then what we need to do is, let's go here. Let's copy the whole table. Okay. So what we need to do is IoT. Let's change it to IoT. Then DFF. Then DCD. DCT. The last one is PIF. And here it is PIF. PIF. PIF and TASC. Okay, then need to copy the whole thing. Okay, now p-value shows that there is a relationship, right? Significant relationship. We have these two relationship. This one is support and this one is also supported, but these two did not support, not support because it's not less than 0.05, right? Not supported. And this beta value is also important here because it shows that it's supported, but is it positively supported or it's negatively supported? If it's positive, then it's positively supported. If it were minus 0.015, then it would be negatively supported, right? So these two things we need to check. So this is the hypothesis, table. We can paste it here. Let's put it here. It's outside the box. So what we can do is we can click on table, table design. Okay. Order fit to window. Where is the fit to window? Auto fit to window. Right. Then how to in what we can write it here. So we go here. I've also written hypothesis result, how to interpret it. Okay, let's go here. Okay, the first hypothesis, this one, that's first hypothesis, uh, impact of, assess the impact of IoT, Internet of Things technology on transparent physical and information flow was positive and significant. Positive how? This is positive and significant how? It's not significant because it's less than it's not less than 0.05. So positive but not significant. Why? B value is positive. It doesn't matter it's positive or not because it's not significant, right? Just sake of writing, write it. So not supported. Hypothesis result are present. Yeah. And the second hypothesis, the second hypothesis assess the impact of digital financial flow between on physical, and this one is positive and significant because positive because this is a positive number and significant because it's less than 0.05. That means it's supported. So supported H2. Okay. So that is how you will do the rest of the. So with that, we have completed the whole analysis part. So Ghazi sir, should I recap everything again?
I think no, I think it's pretty clear and you had slowly discussed, so it is already very clear now. Right.
Okay, okay. Sure. So that's the whole thing.
Yeah.
The preliminary tendencies to hypothesis testing.
So this
And the
is all
thing
right.
is,
Yeah.
right, this is all.
Yeah.
The thing is, we have so many thresholds, right? Like
Yeah.
I have already talked about how to deal with factor loading if it's less than 4 or it's not falling in the same group. We have to eliminate it. But what if AVE is not more than 5? Then composite reliability is not more than 0.7. then in the model fit, the degree of freedom is not less than 5, TLI and CFI not less than more than 0.9, and RMSA is not less than 0.1. What should we do then? So, every problem is unique and it will take time to understand what's the problem, but every problem is solvable. So if you face any problem during your analysis, you can talk to Dr. Gazi sir here. You can directly talk to me. You have my email address here, so you can directly talk to me. So we can discuss your problem as well. We can solve it. Yeah.
So you can say whether there is any clarifications or any comments on on the software model or versions like this.
Yeah. Any model, if you use a spaces 21, 22, 23, 24, 26, in fact, now is running 29, right? Doesn't matter. All are the same, similar. So you can use any model. Some people love to use PLS. I also use PLS as well, but not that much. You know why? Because you see, um, in the output section, if you use MOS, we can see easily the fitness index here, right? In the same model. So PLS is difficult. So you have to go through every analysis and find out, calculate this one. So that's why I prefer MOS. Yeah, but I use both of them. And sometimes people use eViews as well. So that's another software. Anyway, this is the most common one, MOS. Yeah. So do you have any question? Anyone has any question? If it's about particularly, if you're doing your analysis and facing particularly some problem, we can discuss later on, because it will, I need to understand what's the problem first, right?
If there is any comments, clarifications, anything we can discuss now, and definitely I will forward to you the recorded version of the session and all the Excel file that Mr. Hasan Ikram developed for us, so we can also provide you all this. And after we also give you the certificates for joining this session. If there is anything, please.
I think
show
people will
your hand.
face problem first. When
Yeah.
they will do their analysis, then they will have questions, I think.
So if there is no serious questions at this moment, I think we can end this session, right?
Yeah, we can.
Okay.
Thank you
very
very
much.
much,
Thank you very
Prof,
much. Yeah.
for this
Also.
opportunity. And thank you
you.
everyone for attending this session.
Thank you.
Thank you.
Take care.
Thank you so much, Doctor. Thank you, Mr. Hasan.
Thank you. Thank you.
Okay.
Thank you
If,
so
if you can,
much.
you can turn on your camera for it
Yeah.
photograph if possible.
Let's stop
Uh,
sharing now.
You can take a picture. I think Ikram is possible.
Yeah.
Or no? Mm. Yeah.
Yeah. Yeah, I have the pictures.
Thank you so much. Thank you so much
Thank
for
you.
joining this wonderful session. And hope
Thank
to
you
see
very
you.
much.
Welcome.
Bye-bye.
Thank you so
Thank you
much.
very much. See you soon.
Thanks.
Thank you.
Take
See you
care.
soon. Bye bye.
Thank you, Prof. Kasi and Mr. Hasan, for
Thank
the
you. Thank you
wonderful,
very
Most
much.
yeah,
welcome. And pray for me that I can finish my PhD within this month.
Yeah,
all
no,
the best for you.
we pray for
Okay.
you to finish it.
Good
Thank
luck.
you.
Good luck for everything
you.
you are doing.
Yeah.
Thank you. Take care.